Carrie, could you go to the next page? Okay, look at this graph. This is the graph of Apple from 1980 to 2000, the end of 2019. And if you go to current, it's somewhat similar. Notice that it's a huge gain and it is a lot of jagged though. Now, I have some personal thing in here. When my daughter was in high school in Vancouver, in Crofton, a girls' school, I was consulting for Frank Russell pension fund, and I was making 9,600 a month for 6 days to work on interesting papers, and it was a lot of fun. And for her college, I would give her a check for 9,600, and she would buy Microsoft or uh, Disney or Pixar or something for her college fund. Well, two of the checks she put into Apple. Uh, so 9,600 times two in the year 95 approximately. She was smart enough not to sell it throughout the whole period. And she had basically $3.5 million worth of Apple stock, or 4 million, somewhere in that range. So it's an amazing run if you did nothing. You bought the stock, it went up and down. So then my question that I pose in this paper, I know that you make out like crazy by holding it a long period of time. My daughter held Microsoft a lot of time. It's not as good as Apple, um, and some of the others, um, and so forth. So holding good stocks for long periods of time can be really good. So then I was going to figure out a way to beat that if I could. Okay, so if I go, Harry, I'm going to go quickly because it's late for all of you people. So can I
Good.
go next one, next one, next one? Now, keep going, keep going. Okay, now what these pages are that Harry's just gone past, in the year 2012, we found that Apple was going up like crazy and peaked at 708. And we applied a mean changing model that I did with two Russian colleagues. Basically, my idea, but they helped with the math. And we found that we exited at around 690. And the paper is in Great Investment Ideas. And we found that in the next year, Apple fell to 380 from 700. So that's that paper. If I can you go back a couple pages and then forward again? Keep going back. Okay. Now the I argued to you earlier that mean estimates are really important. So here I've got some stuff here on that. So can I go forward? Because I'd like to show you one interesting thing. Keep going forward, please. Okay, now this was, go back. If you look at this picture, these were 2012, and the dots, you see there are a lot of dots, and one square. The dots are potential places where you could invest. So you bought then, you bought then, you bought then, and it keeps rising, it keeps rising. And when does the model tell you to get out? Okay, so we have this Russian stopping rule model based on means. When the mean changes from going up to going down, you exit. So the way it is you climb up a path at a certain rate, you're at the top, and then you come down. etc. So that was the picture there. So now what I want to do is go and show you for COVID what we had. So if you go forward, Harry. Okay, keep going forward. Keep going forward. This is, read this if you're interested, primer on the math, of how the math works. Continue forward. Keep going forward. A little more in the math. Now, here's the COVID period. Can I help you?
You finished?
Not yet.
Not yet. Oh, I will finish very soon.
Now, let's go to the next page. Okay, so here's some Apple and the S&P. So the way this model works, when you have a blue, it means go long. And then when you go up to a point where you exit, and then you go short. And then you go long. So I don't know if it means here. So here's the first picture. This is Apple going long and exiting. And this is Apple going short in the bad period around February, March, April. And then this is Apple going up to now. Okay? So that was fine. And then the bottom one is the S&P 500. And the same thing. You enter with the blues, you exit with the reds, you go short there in the bad period, and then go long. So the question is, did it work? And the answer is yes, it worked. And I've got the results here of how much you would gain versus buy and hold in that period. So I really like this paper, and hopefully I'll get it published as well. Harry, I'm done this paper. I'm going to go back to the thing. If you want to hear about optimization in racing, we can continue there for a couple minutes, or we can quit. You can decide.
See, I think I mean, while we're here, I'm happy to listen.
Okay.
So
why don't we do that, Harry? So next, importance of mean, we can skip. We know how to do that, right? Favorite long shot bias. Favorites are under bet. Long shots are over bet. Let's go to the next. After that. Now, look at this curve, these curves. These are the curves of track payback, less breakage, okay, for horse racing. In the left one, the top graph is the 1986 graph. And in that graph, you could gain by betting on every horse that's extreme favorite, 3 to 10 or less. But over time, the curve changed. Notice that the long shots on the right still have way low expected value, and you want to short them. But the favorites are not as good there. Okay, so that was, if you look at the left side of this graph, that's lower. And then on the right, this is by some Australian friend of ours, Snowberg and Walken, who did a paper in my book and also published in the journal, and they have similar curves. Okay, why does the favorite long shot bias occur? There have been all sorts of studies of that as well, and we Thaler and Ziemba talk about it, and as do others. Can I go to the next page? So forth. Now I want to show you, and here's a whole bunch of literature on favorite long shot bias. Now, the system we did, go to the next page, please. You remember this formula we did? This is the formula for place and show optimization. If you had some magical way of inputting the data electronically in 5 or 10 seconds and then computing, you could do this. But what Hosh and I did, if you go to the next page, I wanted to have an approximation for the expected value. And Don and I ran hundreds of races, and we calculated the expected values, and then we ran a regression, and we got this. The expected value to place is 0.319 plus 0.559 times WI over W, PI over P. So what is that? WI over W is the fraction bet on the horse to win, and PI over P is the fraction to place. So when the fraction to place is low, this is high. So in terms of practical case, and we discussed this in our books, you simply look at those four numbers and you can determine how to bet. You can use a calculator, or you can do it by approximation. And then continue on, Harry. Here's an example. Sonny's Halo, running in the Kentucky Derby. About 1/4 of the money is for win. 1/6 of the money is for show. So the expected value per dollar bet was 114. The optimal Kelly bet is 52 per 1,000. Horse won the race, paid $4 to show. It was easy to make these bets in the old days, because when you go to the Kentucky Derby and there's 15 seconds to go to the race, no one is at the windows so you can bet. They're all watching TV. Okay, now I'm going to talk a little bit about pricing wagers and then maybe wrap it up for you. Harry, can I go to the next chapter? Okay, now this is a bet that you want to do place and show, place pick all at Santa Anita. And this is the probability that a horse comes first or second. Discounted Harville, and then you can calculate the probability that a given ticket wins, and then you can optimize. Okay. Next page. Now, here is just a formulation of a Exacta bet. Exacta is horse I in the first race, J in the second one. You do the optimization here, and you just write out the formula, okay? And then you do it. Next one. So forth. So the idea, Harry, is for every type of bet, write out the formula of how it works, do the expected log, and then optimize, okay? So it's pretty simple, okay? So that's sort of what we do in all these bets. And we have computer codes to do these bets, you know, in terms of the way we do it, etc. Okay. So then the ticket approach, can you go back to the last page? The ticket approach is a little bit different. What you do is you have ones, twos, and threes, and you have so many in each category over so many races. Okay, so then what you do is you create this kind of large ticket with the combinations. The difference here is you have equal bets on all the same combinations. So you have score 6, which is all ones. Score 8, which is a 2 and a 2 and 4 ones. And so you get the idea. I'm sorry, unfortunately, my cold is bothering me. I have to take a cough drop here. Sorry, Harry, could you just go on and I'll, okay. This was an interesting example. On September 11, 2011, the 10th anniversary of the attack on New York and Washington, the first 3 races at Belmont had winners 9-1-1. So the newspapers said that the chance of that occurring was 1,000 or 1,000,000 to 1. Anyway, what I did on this page is I calculated exactly by the formulas, and I get that it's 1 in 28, not 1,000,000 to 1. Now, if you go to the next page, here's a multiple ticket approach that we did. There's 6 races, 3 to 8. The payoff were 360, 460, 12, 9, 18, and 7. There was a pick 6 paid 86,347. The parlay, if you multiply the races together, was 15,000. We bet $1,922. We got a rebate of 154. And we collected 1 pick 6 ticket, 86,000. 11 5 of 6s, which was 692. So we collected in total 93,000. Now the question is, how did we do it? It's not easy to win the pick 6, but we did it. The reason we were able to do it was we had a score 9 ticket. So if the score is 9 or less, we can win. So what happened? The box is the winner. So in race 1, we have a 1. Then we have another 1. Then we have a 2. And then we have a 2. And then we have a 2. And we have a 1. So we have 3 1s and 3 2s adds to 9. So the key for winning was to win race 7. And in race 7, Love at Noon, the 2 horse, was 3 to 5. And Filigree was 4 to 1 in the morning line. Go to the next page. This is hard to read, but Love at Noon went off at 1 to 5 in that race. So everybody was lined up on 1 to 5. We put Love at Noon as a 1, but we put Filigree as a 2, and Filigree went off at like, it's in here, I think it's 18 to 1 or some large amount. But if you look at the final times in the previous races, Love at Noon, the fastest races he did, these are the final numbers at the top, are the fastest of the previous races. And Filigree could run faster than some of the Love at Noon races. So that was the key that allowed us to win the bet. Now, Harry, maybe what I'll do is stop now and talk to you for a couple minutes and then wrap up because we're late for everyone. Thank you for having me. It's always good to do this stuff. I hope your people enjoyed it a bit.
Well, I enjoyed it, and I appreciate all the time and the different topics. And so I just wanted to thank you and thanks again for coming, and thanks to everyone for being here. I'll stop the recording, but we can continue to talk afterwards.
Yeah.